All right, so you should have completed and submitted a Google form on page 3 for this top set of questions on reflections and translations. And now here we are towards the bottom of page 3 on dilations. Now dilation, down here I've got some examples of some Russian dolls. Y'all, the dilations are going to be the only change that will actually change the size of our figures, okay? Back on the previous page with translations, we have congruent shapes. They're the exact same size and shape. And back on the first page, we had reflections, which are also congruent figures. They have the exact same size and shape. All we do is change the location when we reflect, and we change the location when we translate. Now with dilations, we're going to change the size. Right here, the size of a figure by a scale factor to create a similar figure. Notice we're no longer looking at congruent figures, we're going to create similar figures. Our sides are going to remain proportional. In our previous unit, we talked about similar figures, and we talked about how bobbleheads are really funny because they're not proportional. Russian dolls down here serve as an example of figures which are proportional. Now the scale factor is going to be given to you guys as fractions for the most part, and if they're not fractions, we'll make them fractions, okay? If you have a scale factor that's less than 1, that means that the figure is being reduced. If you have a scale factor greater than 1, that means that our figure is going to be enlarged. And on the next page, we're going to see some examples on the coordinate plane. To find the image points, which are the new points, all we have to do is multiply our original coordinate points by our scale factor. Let's take a look at the next page at some examples. So right now, you're going to graph triangle FUN on the coordinate plane. Point F is over 3 up 3. Point U is over 3 up 1. Point N is over 1 up 3. Now what we're going to do is take each one of these coordinates and multiply by a scale factor of 2. So 3 times 2 is 6. 3 times 2 is 6. So now we're going to go over and plot the point over 6 up 6. That's going to be F prime. All right. Now we're going to take point U and multiply by 2. So we're going to get a 6, 2. All right. So we're going to move over 6 up 2. Then for N, we're just going to multiply by 2. Once again, we're going to get 2, 6. So if we move over 2 and up 6, there's N prime. And when we connect, we can see that we have an enlargement. It got enlarged because our scale factor was bigger than 1. Now another thing I'd like to point out is that right here, if we look at side U prime to F prime, U prime to F prime is currently 1, 2, 3, 4 units long, and that should be twice as long as the original side. So from U to F, right here, we can see that that's a distance of 2, and what do you know, the sides are still proportional. All right? Now let's try another one where the scale factor is going to be a 50%, and here's what we mean by writing that as a fraction. So now what we're going to do is we're going to take half of all of these points that we see in triangle CAT. So go ahead and plot your points. Plot C, you're going to move back 6, down 4, and plot point C. Then you're going to stay on the origin and then just move up 8 on the y-axis, and that's going to be point A. And then you're going to move over 2 and down 8, and that's going to be point T. So now we've got triangle CAT. Now what we're going to do is simply take a half of each of these values. So a half of -6 is -3. Half of -4 is -2. Let's keep doing the math. Half of 0 is 0. Half of 8 is 4. Half of 2 is 1. And half of -8 is -4. So now let's go plot the image points. So we have -3, -2. That's going to be C prime. Then we have 0, 4. 1, 2, 3, 4. It's going to be A prime. And we're going to move over 1, down 4, and that's T prime. And now we can see here when we connect, and I'm actually going to undo that and get a straight line tool and connect using that. So from C to T, here's C to A. Boom, there we go. And we can see that that original triangle was shrunk down. The other thing I'm going to do is I'm going to just kind of roughly retrace the original triangle CAT right here. That's just a rough sketch. And now what I'm going to do is I'm just going to make this one triangle. And I'm just going to show you guys that this figure, whoops, undo that. I want just these three. Sorry, one sec. There we go. And now let me put this back. All right, all I'm trying to say is that this figure, if it's getting reduced, it's going to be smaller than itself. So take a look, there's the reduction. Or you can take a figure and enlarge it, and it's going to be bigger than itself. So these are similar figures, folks. They're no longer congruent. They are similar figures. And where you plot either the reduction or the enlargement, if it got enlarged, you just look at the coordinates and it tells you where they go. Okay? Now I'm going to delete that and delete that. And we can see there for the second one that this was a reduction. It got reduced because the scale factor was a fraction. All right? And now down here for the last one, you have your pre-image, point D over 3, up 3. Let me fix this. Then we have over 6, up 3. I'm actually going to just erase that. My points were off slightly. It might have been because of when I moved the graph a second ago. But let's just replot these points. So over 3, up 3, that's point D. Over 6, up 3 is going to be O. And 0, 6 is G. And now we've got the pre-image. Let's make sure we label those points. So point D, O, G. All right, and now we're just going to take a third of each of these. So 3 divided by 3 is going to be 1, and then a 1. 6 divided by 3 is 2, and then 3 divided by 3 is 1. 0 divided by 3 is 0, and 6 divided by 3 is 2. And now we can go plot over 1 up 1, over 2 up 1, and 0, 2. And even though it's a teeny tiny little guy, we can still see our triangle. And let's make sure we label it D prime, O prime, G prime. So we've got similar figures here. This one we can see was a reduction because the scale factor is less than 1. Dilations create similar figures. All right? Now what I want you guys to do is I want you to turn to the next page and I want you to attempt to answer these questions. I'd like for you to attempt to answer these questions first on your own. Sorry about that. I'd like for you to answer these questions first on your own and then watch the video and check. Sorry about the delay there in the video. That was weird. My system glitched on me. But for number 1 here, I want to know what would be the length of side A prime, B prime if the triangle is dilated by a scale factor of 1/2. So currently side AB over here, if you just count, it's 1, 2, 3, 4, 5, 6, 7, 8 units long. Okay? So AB is currently 8 units long. If we dilate that by a scale factor of 1/2, then side A prime, B prime would only be 4 units long. Okay? That's all we're asking. It's going to be half the length. For the next one, BC, if we take BC and dilate it by a scale factor of 2, how long would B prime C prime be? So currently, BC is 1, 2, 3, 4, 5, 6. Currently, BC is 6 units long. So if we double that, then B prime C prime is going to be 12 units long. All right? For number 3, I'm asking, what will be the location of B prime if the triangle gets dilated by a scale factor of 2? So currently, where is B located? B is currently located back 2, down 2. Now, if that gets multiplied by a scale factor of 2, then B prime would be located, this is the answer, at -4, -4. Okay? All right, for the next one, what would be the location of C prime if the triangle gets dilated by a scale factor of 1/2? So currently, point C is located over 1, 2, 3, 4, down 2. Okay? So C is currently located over 4, down 2. That means C prime would be located at 2, -1, because all we got to do is take 1/2 of each of these coordinates. All right, for number 5, reflect the pre-image over the x-axis. Where will A prime be? Now with this one, A is currently up here. It is currently located back 2, up 1, 2, 3, 4, 5, 6. So A is currently located back 2, up 6. If we reflect it over the x-axis, I want you guys to think about earlier for one of the videos, we talked about if it flips over the x-axis, this y-coordinate up here is going to move down here. So the y-coordinate is all that flips. And then that means that A prime would be located still back 2, but then down 6. So if this point gets flipped over the x-axis, it's back 2, and then down 6 right here. That would be A prime. Okay? For number 6 here, it's saying to reflect the pre-image now over the y-axis. So now we're going to be flipping it over the different axis. When we flip this over the y-axis right here, instead of A being, now we're looking at point C. We're looking now for point C. So C, it started out over 1, 2, 3, 4, down 2. C started over 4, down 2. And now what we're going to do is reflect it over the y-axis. So now, instead of being over 4, down 2, it's going to be back 4, down 2. So C prime will be located back 4, down 2. For the y-axis, it's just the x-coordinate that flip-flops. So back 4, down 2, and that would be C prime. Okay? We can reflect the triangle over the y-axis, and it would just look something like that. That's just a rough sketch. Okay, I'm just reflecting that triangle over the y-axis, and that's a rough sketch. And now let's take a look at number 7 here. So, for number 7, what we're going to do is we're actually going to complete 2 transformations into 1. All right? For number 7, what we're going to do first is we're going to translate the pre-image triangle back to up 2. So this entire triangle is going to get translated back to up 2. So B, I'm moving it back to up 2. There's B prime. A is moving back to up 2. There it is. And C, I'm going to move it back to up 2. There it is. So that is me moving the triangle back to up 2. And let me just connect those dots real quick. Awesome. So notice with the translation, we still have congruent figures. But now what we're going to do is dilate this triangle by a scale factor of 3. After we dilate it by a scale factor of 3, the only thing I want to know is where will B prime be located. So B started out here. We moved it back to, up to, and now here's where we're at. This ordered pair from the origin is at negative 1, 2, 3, 4, 0. This point is at negative 4, 0. If we then multiply that by a scale factor of 3, this point would be located, B prime would eventually be located back 12. And then since 0 times 3 is still 0, it'd be negative 12, 0. Okay? So now that we're done with the dilations, let's kind of sum up here now and review the 3 transformations that we've talked about so far in this unit. All right? So transformations are simply changes which occur to our figure on the coordinate plane, and we've talked about 3 types. We talked today about reflections, translations, and dilations. For reflections, the preimage is going to get flipped. All you need to know is which axis to flip it over. And of course, the preimage and the image are going to be congruent figures. They're the exact same. With a translation, we just slide that figure around. So when a preimage gets slid around, you know it's translated. You just need to know the translation as an ordered pair. And once again, you're going to create a congruent figure on the coordinate plane. Now for the third type of change that we've had on the coordinate plane, you take a preimage, and all you need to know is its scale factor to dilate it. If the scale factor is less than 1, you have reduced the figure. If the scale factor is greater than 1 and everything gets multiplied by something bigger than 1, it's going to be enlarged. Now, while reflections and translations create congruent figures, a dilation will create a similar figure that is proportional to the preimage. If the scale factor is 1, then nothing happens, and the figure is itself. You have the exact same shape. And you are now done with the transformations unit.